Swayam Prabha. Digital India. Educated India.
So today we are going to talk about what happens when the whole life cycle stages when you were introduced, right? What are the 5 life cycle stages you are aware of? Those are the steps. What are the life cycle stages in a product? Raw material acquisition. So you do a lot of mining in terms of metals, or drilling in terms of oil, and a lot of other processes in which we extract. That is the first. It's like they also call cradle to grave. No, as you, like a human being starts life in a cradle, goes into a grave, right? So starting is acquisition of raw materials, then manufacturing. It can involve a series of steps in different places also, and then get assembled and all that. So then transportation runs through the whole system, right? Transporting raw materials, transporting goods and all that. Okay, and then comes the use, finally reaches the place where it is supposed to have a meaningful functional value. Okay, it can be industry, it can be our homes, offices, right? It ends up in a place where use can happen, and that is also where people, at the end, it reaches its end of its life, right? And it people try to put it away because it's not useful to them anymore. And a lot of discussion would be around what happens when it reaches that end of its life. Okay, so how does a product reach its end of its life? There are various reasons why the product reaches its end of life. It gets damaged and it's not functional anymore, what it was intended to. Then shelf life, let us say, if it is a biodegradable product, right, like a food product, there is a shelf life, and so it's similar to getting damaged, the other products. Yeah, then yeah, sometimes your when the efficiency of its performance, right? If it's a machine, then you discard it and get a new machine. Yes, then obsolete. Yeah. Hmm? Outdated or obsolete, right? So yeah, technology changes so fast, right? So many of the products what was considered valuable doesn't even exist anymore. Can you name any one of those products which was considered to be very, very, yeah, floppy disk in computers? Then film cameras, yes. iPods, yes. Radio, I think it is still used, not as a box, but yeah. Cassette, yeah, video cassettes. A lot of products, right? As technology changes, it becomes obsolete. And you can't just keep it. I think we are still keeping, many of us, even in my home, we still have it like a memorabilia, right? For some reason, you don't feel like throwing it away, right? So, but it is sitting there without any function. It reached its end of its life. Any other reason? It's just, yeah, you just wish you want a new dress, right? It's Diwali or Pongal is coming up, so you want a new dress, even though you have a lot of new dresses. Yeah. Yeah. So there are a lot of different ways how a product reaches its end of life and you're ready to throw it away. Okay. So that's when the entire nomenclature changes from whatever name it has to just a waste, right? It can be anything, but now it's a waste, right? So it's waste is a very hard terminology, because overnight, no, the product becomes a waste. Okay, so yeah, We have summarized almost everything. Physical life, when the product breaks down or stops to work. Functional life, when it ceases, when it loses, it can be physically fine, but its function is done. Like packaging, right? Once an Amazon package comes to your door, you just take your product and throw it away. It lost its functional value. Technical life, advances in technology makes it obsolete. Yeah, I've given pager as an example. Economic life, economical life, it's a complicated thing, right? So refurbishing becomes expensive. Even if you want to refurbish and continue use the product, refurbishing becomes expensive. The parts become expensive, right? And it's even economical to go and buy a new one than looking for parts, right? Many of our electronics, large in our laboratory also, I think large equipments, we are buying, putting in like hundreds of thousands of rupees, dollars, and it becomes obsolete because we can't find one single part, right? Legal life, new laws have made it illegal to use, right? I have a car, I think it was bought in 2000, okay, but the emission norms and all that says that it is not permitted to be used. The registration doesn't, they don't even extend its registration beyond certain value, right? Number of years. Hmm. Yeah, yeah, that's exactly for environmental reasons. Maybe we should add that. Okay, the environmental life, we can call it, right? All these outdated chemicals are still in use, which have been banned recently. If it is still in existence, you can't use it, right? And then the last one is desirability. You just don't want to use it. It becomes old fashioned, right? It can be things, it can be car. Nobody drives an ambassador anymore, right? Nobody thinks it's fashionable to drive an ambassador, right? It may be running, it may have a functional life and everything, but you don't want to, right? So this is the most dangerous one, right? Because you're just wasting the product. So for several reasons, it reaches end of the life. And this is the last stage in your life cycle assessment. When you're doing your life cycle assessment, you will be looking at all those, like you started thinking about your product for the project, right? So a product was given to you and you started looking at what goes into making that product, right? That is the first stage. And then the second stage is how did they make this product? Okay, and every stage, what is being showed here, incurs energy, right? Mining, processing the bauxite and getting aluminum, all that incurs energy. Every stage incurs, this is something I'll get to the next slide. But what every stage incurs energy, you all agree with that, right? We talked about it yesterday also. Energy was a big component and it comes in every life cycle stage. Then what else happens in every stage? The first stage, there is a lot of, if you remember my first presentation, the introductory presentation, right? We talked about the triple planetary crisis, and then we talked about the resource deficiency or resource limitation, finiteness of our resources, okay? The non-renewable resources and even the renewable resources, we said it has to be renewable in a time frame in which it is used by the next cycle, right? So then only it is actually renewable and usable, right? So if you put that in that concept, we talked, what are the three planetary crises we talked about? Pollution, right? And then we talked about resource depletion. That's an important component. So every stage of life cycle of the product, and we also talked about planetary boundaries, right? How many planetary boundaries we have and how many have exceeded? 7 already, right? Good. So, and in life, when life cycle impact assessment, Professor Su was talking about all the different impacts. So, anytime you look at a product, like there has this should go behind us in your mind, right? There is resources which are being used. In the first stage, it is mind, which incurs a lot of energy. It incurs a lot of carbon dioxide emissions whenever energy is used, and it also emits lot of other things, right? Production process involves emission of gases, and it involves a lot of water, right? There are other resources, not just material resources. Water is being used. So everywhere there is usage, there is wastage and emissions, right? So as we go along making the product, or even in your project, you are going to be thinking about all that in different stages. Packaging is another big thing. Transportation involves a lot of energy and emissions. Major one would be energy in and emissions, carbon dioxide emissions, which is the global warming effect is talked about a lot. So, and then you have all the toxic emissions, and you have water usage in some cases may not. So these four things at least you should keep in mind. Every life cycle stage, there is resource consumption, energy consumption, a carbon dioxide emission. Okay, there are some toxic emissions. Okay, both water and gaseous. Okay, so all that, when you come to the use case, okay, again there is, we have to think about all this. And so when it comes to the end of the life, you're done incurring all this throughout the life of the product, right? You have placed a lot of demand on the planet all along. Okay, and then when it comes to end of life, what happens? When you're just tossing it out, the garbage guy comes and collects it. Do we even think beyond that? What happens to it? You toss off a torn t-shirt, or you don't like the t-shirt, just throw it away. When you throw that away, what goes out? Is it just the t-shirt? Yes. So if you had look at an alternate, all the things which was incurring in the production, okay, manufacturing, you've used a lot of things, and when you throw it away, embodied energy, instead of, just look at an alternative scenario where you're gifting it to somebody. It's a good t-shirt and you're gifting it to somebody, and somebody who's probably cannot afford it, or sometimes, like what Professor Su was saying, thrifting has become more and more common. Even in IIT, we have a group, thrift club. How many of you know about it? IIT students, are you part of the thrift club? Yeah. Hmm? Member, good. So every day you see lots of messages. People don't want something and they just want to give it away at a lower cost. People are there willing to take. Particularly in our country, we have all the different classes of people. So there are people who cannot afford it, and they are going to give a second. It goes into they're going to use it. So all this upstream expenditure of energy and emissions and all that is gone if it is directly going into the reuse mode, right? And the product gets a new life, reincarnation, we call in our tradition. Okay, so you can think about it in different ways. So end of life, what is not currently happening is all this. No, we wish these things happen, but what we are seeing currently is this, right? Most whatever we toss out of our door ends up in not even, I won't call them landfill, it is a dump, right? There's a huge difference between landfills which are engineered and dumps like this. This is Delhi's Ghazipur, right? Have you seen this picture anywhere? Yeah. So allowed height of landfills is 15 meters, slope stability and all that geotechnical stuff what we studied. But this is 65 meters, and I think now it has reached the height of Qutub Minar. This is old data. It has gone beyond Qutub Minar. And not only that, there are lots of waste which are not collected. They call it waste leaked, and which ends up in our water bodies, it ends up on our beaches, forests, and many of them burn. Right, in places where particularly garden waste gets burnt a lot, in places where there is no collection system in rural areas, they have no other option but to burn, right, because nobody comes and collects it. And yeah, in Chennai, similar scenario, we have flatter dumps rather than tall dumps. That's the only difference. We take a lot of land space. We'll be visiting one of the dumps, the two big dumps in Chennai. Tomorrow we'll be visiting them, one of them. And so they are flatter, but they're still, it looks very flat here, but it is actually around 20-25 meters high. Okay, and it is in a pristine marshland, which makes it even worse. The wrong place for a dump. And when you dump such things, you see all this. There is manual scavenging, which is happening in the dump site, which is really, really bad from the social point of view. Then we have methane emissions because it's all mixed waste. And in summer months, most of the days it's like this, fuming, small fires, and then sometimes you see big flares. In summer, you'll see these repeated fires in dumps. Many cities you'll see that. Okay, so and it is right in the middle of the city, right? Perungudi dump site. At least Kodungayur is in the northern part of the city. There also there are population, but it is not that visible. But this is quite visible. So a lot of impacts. I don't want to go over it again. Uncontrolled burning can lead to a lot of this air pollution. It reaches even up to our glaciers, right, where not only climate change and rising temperatures are causing the glacier melt, our own burning. What happens? How does it contribute to the increased glacier melt? Any guesses? The burning of even this agro biomass. Exactly. It's a lot of particulate soot, black carbon, which is emitted, travels long distance, gets deposited. Okay. And anything which is black on a white surface, right? We all know what happens. No, the temperature, the melting of ice happens rapidly, right? And now we have a new threat of the volcano in Ethiopia depositing all this in India, which is pretty scary. I'm not sure what is the current situation. Yeah, and finally, whatever we put in the water body, this is the Great Pacific Garbage Patch. How many of you have heard about this? Okay, so still a lot of you are not aware of this. This is a huge floating plastic mass, I would say, 170 trillion plastic pieces. It's almost twice the size of France floating in Pacific Ocean, and it has caused a lot of damage to the flora, fauna, the living things, and it's really a bad eyesore on how the anthropogenic impact can affect the oceans. Okay, so end of life, mismanaged end of life is what we have seen. The other side, if you look at the Western countries, for a long time they were very good in the collection part, making sure that nothing leaks into the environment, and sending it to landfills, properly designed landfills, right, which has protection, the barriers at the bottom, cover on the top, so nothing leaks into the environment, collect the gases and at least burn them, if not use them. But is that an agreeable way of treating the waste? We were talking about the different things which are incurring, right? Expenditures incurred are impact on the planet. How much of this material, if everything is just put in, it's like a tomb, right? You just put everything, cover it up, and it sits there for a very, very long time, right? You're not even letting it decompose. It's slowly decomposing anaerobically, but not actively. But all the valuable materials in terms, not only value in terms of resources, again in terms of the uh, emissions it has incurred, right? All the toxicity it has incurred. It has put a lot of demand on the planet, okay, but it is just dumped and sitting there, right? But there are there has been attempts to recover material, right? So sometimes they have collection, at least at the point of collection. Many cities have in the West, they have collect separation at source, right? The recyclables go in one basket, and the compostables or the biodegradables or anything which cannot be recycled goes into another basket. But again, we think that everybody in the West is doing it, right? That's the perception I had. But when I was in New York City last few times, there's nothing like that happening. Everything goes in one bin, right? I was thinking in Chennai is doing a much better job than New York City. Everything goes in one bin. They just collect, they do a good job collecting it and taking it somewhere out of sight, right? So people are happy, the citizens give a clean sheet to the government. Okay, so it's not uniform everywhere. Still, there are cities who are not implementing segregation, but that is the ideal thing to do, source separation. And if it is not source separated, if it is source separated, some of the biodegradables go to composting or biomethanization. And if it is not done right, there is also a facility separation or material recovery center, they call it, okay, or mechanical segregating units. Okay, you will be seeing one such unit tomorrow. And what is the job of it? So it can segregate, it can send some of the things for recycling, and those which have high calorific value and which cannot be recycled goes into an incinerator, and those of which we cannot do anything, either recycling or sending it to an incinerator for waste to energy, goes into the landfill. Okay, so it is an integrated solid waste management, they call it. Okay, but not much is being done in terms of reducing, refusing, and all that. Okay, so these are the pictures of the composting facilities, large scale biomethanization. Tomorrow again, you'll be visiting a large biomethanization plant. And then there is a waste to energy. We saw some of this earlier also, what it incurs. Okay, picture of a large waste incineration facility. And of course, the end is landfill, right? Whatever you cannot do anything goes into the landfill, a proper landfill with liners, gas control systems, groundwater monitoring systems, very important because even this can leak, right? That is always prone to some kind of a error or life. There is also life for the liners. So we have to make sure that there are monitoring done. Okay. And yeah, a big part of solid waste management by the government is recycling, right? So plastic recycling, we have seen this earlier also, I think. But look at what are the options. There are the triangle with a number, all of you are familiar with. It indicates what is the material, right, in the plastic. If you have I'm glad nobody has a plastic bottle, but if you look behind it, you will find these triangle with a number with different categories of plastics. Okay, and which are recyclable and which are non-recyclable. There is a description if you look it up in Google. Okay, so most of these plastics, when it comes at the end of the life, right, what happens? So these are all the different options, or may or may not be practiced depending on the place we are in. Landfill goes to the landfill without any other processing. Incineration with or without energy recovery. Okay, and then chemical recycling. So they process it again to get back fuels, functional materials, okay, and chemicals also, right? So we fuels, because it came from a fossil fuel, it can always be go back and we can extract the polymers. If you can do a pyrolysis, that's a very popular technology where you can pyrolyze, burn it at a low temperature around 500 degrees, not very low, but free of oxygen, right? So then you get the gases can be condensed and converted into a fuel. And some mechanical recycling is missing here, where you just shred it, melt it, and put it back into the virgin material to substitute the virgin material. Okay, and there are a lot of people who are working on making monomers from these plastic and then putting it back into making new products. Okay, that's another advanced level of recycling. Okay, and chemicals, of course, since it's a hydrocarbon based material, there are ways in which you can extract fine chemicals. Again, it is a technology intensive. Okay, and how much of it is really going for all this recycling and how much is going for incineration? This is a statistic. There is always a misconception that plastic is recyclable, right? If you have a recycle bin and you're throwing your plastic in a recycle bin, you think you've done the right thing and it's all safe, right? You've done the good job and we can keep consuming more plastics. That's the myth. I think people in this room may not be aware of, but if you look at the larger population, that's what is in your mind, in their mind. Okay, so you can just recycle. As long as you're sending it for putting it in the recycle bin, you can consume more. You've done the right thing, right? But if you look at the statistics, so this is virgin feedstock, polymer production, okay, it's getting some recycled back into it. These are the gross numbers, an indicative number. Okay, so out of which there can be durable plastics and non-durable plastics. Durable are like the HDPE and the other ones which can be recycled, where mechanical recycling is easy to do. You just separate it, segregate, shred it, and then send it into an extruder and then make it recycle. Then incineration, and finally leaks or dumps, proper landfill. So this is the breakup. So you can see that only 16%, this is a world, it's a Western statistics from the Western countries. It says that 16% is collected for recycling, when actually 12% is actually sent back and there is a loss there. Okay, so it's a small percentage. Okay, in spite of all the quantum of plastics which are being produced, very little is getting recycling. So recycling is often like a myth, right? And people tend to generate more and more plastic thinking that everything is going for recycling, whereas it goes to landfill. A big chunk goes for landfill. A small percentage where there are waste to incineration plants goes for incineration. And most, like 19%, is leakage. And again, recycling, when you're talking about even the mechanical recycling, which is easy to do, the chemical recycling is the next level, which involves more technology, as I told you. Even the mechanical recycling becomes impossible when it is not separated, right? So these are nice, clean plastics which are baled. These are actually pictures taken from IIT Solid Waste Management, right? So not too far. So if source segregation is done properly, this is how it ends up. And if not, if you're not doing a good job, this is how even the high quality plastics like HDPE, which has a high recycle value, PET, all these are PET bottles. These cannot be recycled, right? Because they are so much soiled that it's going to incur a lot of energy sending it to a washing plant, a lot of water for washing, and it's not worth it. So there are challenges. This is just a plastic example. We can extend this example to other materials which have reached end of life. So it is poor segregation, waste management systems not adequate, recycling plants are capital intensive, right? So it is shredding, baling, and all that incurs a lot of energy, extrusion and all that. So high operative cost, long distance transport, the logistics, particularly with respect to plastic, makes it impossible to do any recycling, right? Because of the sheer mass of the plastics. How much can you load on a vehicle unless you like really compress it, and how far you have to take it? In India, the option what they use for plastic waste, which is non-recyclable, is sending it to a cement plant. The government is very happy. How many of you know that? Cement plant is a big receiver of all our non-recyclable material, right? Whatever cannot be recycled goes into a cement plant. Okay, the government is very happy in showing their balance sheets, how they are managing the waste. That they have sent it, instead of building a waste to energy facility, they have deals with the cement manufacturing industry, where this goes as a fuel replacing the coal or the coke what they are using for manufacturing cement. Right, it's kind of a win-win when you look at it. Right, they cut down on their coal and use this plastic. The government gets rid of the plastic. Okay, but then cement factories are not everywhere. Every city is generating, like Chennai is generating 6,000 tons of waste, right, of which more than 50% is this type of waste, which is has to be it cannot be biodegraded. But the cement plants are down south, probably 200 kilometers, 300 kilometers south of Tamil Nadu, right? So hauling all these 300 kilometers doesn't make sense, right? In terms of, again, your own eco attributes, I call them, right? In terms of carbon footprint, fuel consumption. Okay, it doesn't make any sense. The emissions associated with all this transport. Okay, so long distance transport, although looks good, but practically it is not possible. But still, we are doing it because we don't have waste to energy plants in Chennai, right? So tomorrow you will be hearing it from the people. They are actually mining. We are going to go to a legacy waste mining site where we are digging out the old buried waste and trying to segregate it and send it for different recycling options. Yes, so end of life is challenging. That part I think is clear to you. Even though we have technology, we can't be rest assured that all that is going to take care of. We can keep on producing waste and keep sending it to them, right? It's not enough, right? Because it's not possible practically to manage all the waste just by these kind of facilities, right? So, but the other option, like rightly said, we need to look at other options, right? So, recycle is not the option or the first option, I would say. It should be the last option, right? Because recycling has so many issues, right? It's not so easy, but these are doable, right? Sending it for reuse, reduce, and then people have come up with even 11 R's, just expanding on the reduce concept here, right? So, do you recognize all of it? Refuse, we said that already. Refuse to take waste, to take products, buy products which will immediately become waste. Reduce your consumption. We have been telling about this all along. Repair, refurbish, rent, repurpose, reuse, then comes recycle, right? And all that cannot be recycled goes for recover in this case is recovery of energy. That's when it goes to incineration. So recycle, incineration. Okay, and to facilitate all this, regulations are important. To do all this right, regulations are important. But I've put this in bold: redesign. That's even a higher goal, right? Which is even better. All the R's which went before redesign, okay, or regulate. For to enable all those R's, you should not think about this at the end of the life, right? This discussion about end of life, we started off like, okay, the product has come to its end of its life, and what do we do with it? Okay, it's not enough if we think about the end of the life at the end of the life, but at the beginning, right? The first life cycle stage, that is where people in the production process, okay, material choices happen. What kind of manufacturing process can go into it, right? What kind of assembling can be done, right? Can it be reassembled, okay, rather than fusing everything? All that, lots and lots of decisions go into the design of the product, right? So it is not enough to enable all this, okay? Redesign is a big thing, and I mean, a lot of our energy has to be focused in redesigning products, rethinking products, okay? But what is the current state of affairs? It's nice to have a product. Can you think of new products which are coming up in this with this aspect? Product which is designed to be repaired, which is designed to be refurbished, designed to be repurposed. Any examples of repurposing? Rethinking is part of redesigning, right? When you're designing, you're going to be thinking about what materials I should use, okay? How to assemble these things, right? What processes should go in the manufacturing. Okay, so rethinking and redesign is together. Yeah, can you give some examples? Yes, okay. Redesigning your furniture. So it can be multi-purpose rather than having two different furniture. Ideal for studios and small houses. Right, right. That's a small added value. Right? They're making you dump that pen so that the seed will grow, right? But can you dump a pen in the soil? It's mostly plastic, right? So there is a, what to say, you have to take all this with a pinch of salt. The lot of products are coming out, but are they truly sustainable? Are they truly then thought about this whole process of life cycle assessment? We don't want to plant a pen, right? So we need to be looking at everything with a careful eye. Then anything else? Hmm? Shampoo bars, right? Shampoo bars are coming up rather than shampoo bottles. So you don't need plastic bottle. The material embodied energy of the plastic bottle is saved. The emission while making this bottle is saved. Okay, the transportation cost, because it's mostly water and probably 1 or 2% the chemicals and the detergent, the surfactants and all that, fragrance and all that is only 1 or 2%. It's 100, almost 98% water. Why pay for water, or why pay the transportation cost for such a big bottle, right? Can we just do it with a bar with all the ingredients in a solid form, probably wrapped in a paper packaging, right? So that is rethinking and redesigning. Yeah, that is again end of the life, right? You're not rethinking container design. It is just what do you do with the container after it is done? You make it into a living structure or an office and all that. But redesigning it, can you think of examples where we need to think about it so that it can be refurbished, repaired? Many, even your own cell phones, right? Apple makes cell phones where you can't even change the battery. The whole product design should change so that parts can be replaced. But our Indian phone refurbishing shops are amazing. Even an Apple phone, which my daughter discarded because it kind of expanded, the battery expanded, and it was in a very pathetic state. The camera was not working, and now nobody in US could repair it. And when I went, I bought it, and the one guy in Adyar was just like 10 minutes away from here. He did an excellent job. He changed everything, and now it is like a brand new phone. I can show you. You can't even make a difference, right? So that's the smartness of our guys. But yeah, but how many of us do that? We no, you always want that new phone, and you just don't want to make that effort and money. It cost me, I think, 12,000 rupees to fix it. But it was worth it, right? Apple phones are expensive. So yeah, the modular homes are coming up. I don't know if you have heard of it, right? So you can remove, if you're going to demolish this building, it's just going to be broken bricks and broken concrete, and it takes enormous amount of energy. Imagine, no, crushing all these construction and that's what they do in the landfill places, right? So they have to crush the concrete, separate it, and then see what they can do with the crushed material. And often it is of inferior quality because it's mixed with brick and mortar and everything. Okay, but imagine a home like a Lego block. Can we disassemble the home? Right, because walls are just fillers, right? They're not load bearing, so nothing, no damage happens to the bricks, right? Is it possible to disassemble and reassemble in the same place? When you're building the new house, you can use the same bricks. Okay, so those kind of redesigning is happening, rethinking and redesigning is happening at all levels. The sustainability concept is catching up, from mechanical, from cars to buildings also. People are thinking about changing the way they think. Okay, so I think I've already covered this part. I just wanted to say that tossing was not a part of our culture, right? All this happened in India. I don't know how many of you are still one generation away from me, but how many of you have seen people coming on the road, on your streets, in near your houses, who can collect all your old clothes? How many of you have seen that system? Okay, good. So it is still happening. Okay, I'm glad. I thought it was my school days. So people collect old clothes, and what do they give in return? That's all. Okay. It used to be utensils, stainless steel utensils, plastic buckets, plastic, colorful plastic items, which is not good, but still, the clothes go, and there is a whole collection system. A lot of these people, there is a centralized collection center where they deposit, and then it goes, somehow finds its way to a recycler. They're not doing all this to put it in a dump. Of course, there is money flow coming in, right? So they're able to give us something back. And people, even now we are saving all the newspapers, right? And that is still flourishing now. That's not changed a bit. Plastic thing is what, the plastic sachet the milk sachets, that is what went for a toss. I think there is no collection system. People are not collecting these milk packets anymore. How many are collecting milk packets? Do you know? Have you seen people doing it? Earlier it was there. So somehow the plastic industry is expanding so much that why is it not happening for the plastics? Can you tell? Paper, it is definitely happening. India is doing a great job. We are not throwing, very less paper goes into the dump. Even when you go to the dump site tomorrow, you can have a look at it. Like, it's like 20 years of waste sitting there outside. So you can identify what is not getting recycled, just one look at the dump site. Do you know what is not getting these? What will you see in a dump site if you have seen pictures of it? Plastics, yeah. Then clothes, lots and lots of clothes. Then footwear, footwear, electronics, small components of electronics. You will find somehow electronics are finding its way to these recycling centers, although they're not doing it the right way. Somehow nobody tosses anything in the dump, right? We don't toss our DVD players, or even though it is out of function, we just keep it, right? Somehow, maybe it's a cultural thing again. We don't toss electronics. Then glass, yeah. Glass also, I think broken glass, a lot of broken glass gets tossed, again due to lack of proper collection mechanism, right? So yeah, but traditionally we have been doing a lot of recycling, right? Even clothes never used to go out of our house in the dustbin. Nobody throws a even a used cloth in the dustbin, right? It becomes a rag, it becomes a cleaning thing, right? Yeah, it goes from the older one to the younger one, and then it becomes a doormat. It becomes finally, it gets into like really, really rag like thing, and only then we toss it, right? But somewhere down the line, we lost all that. No, the current generation has not, maybe you are not still there. I'm glad, but the young ones don't understand the value, the current upcoming, if you talk to school kids, the value is lost. Okay, the value of recycling is lost because not only that, it's not just the value, it is the most important thing is, um I thought I've put it in somewhere. uh Footwear, one example, what we see in the landfill is footwear, right? Because there is a shop in IIT Madras where they repair bags and footwear. Okay, and he has done, his father was doing it, now he is doing it, and they have done thousands and thousands of repair works. But then when you talk to him now, he says that he is unable to repair the footwear. Okay, he's been doing it for generations and he says he's unable to do the footwear repair. Why? It is made in such a way that it cannot be repaired. It cannot be put into a machine or hand stitched or whatever. What he was even glued. Glues don't work because there are molds, there are multi-material, new material coming into the market, and it cannot be handled in the regular repair shops. So products are not designed to do all this, or not designed to last, or not designed for repair, not designed for refurbishing. They are designed for the dump, designed for the dump. Okay, that has been the norm in all industries, electronics industries, footwear industries, clothing. Yeah, more and more mixed fabric is coming, right? You don't have a single, like a cotton sari like this, or no, polyester comes in different percentages of mixes, that it's difficult. You only PET, now everybody talks about recycling polymer and making clothes, but only PET bottles are taken for making fibers for clothing, right? No other plastic is taken for clothing. Again, it's a misnomer. They advertise a lot saying that it's recycled polyester, right? Even suits and high-end products come with recycled polyester. But it's only PET bottles which go. So you won't find much PET bottles in the landfills. You'll find all other plastics, but not PET bottles, right? So the products design play a very important role, and we can't just look at the end of the life. Okay, and that makes a huge difference, and it makes all these things possible, right? And the value of the material, plastics don't get recycled, your packaging doesn't get recycled because there is no value in it. There is nobody wants to pay money for it. Whereas if you want to give paper for recycling, even now you get some money back. Nobody gives money for your packaging waste, right? Because there is no supply chain market available for this to go and get remanufactured and come back, right? So it is important to understand that. And yeah, so this ideal management is important, and make sure that there is very little which goes into the landfill, right? And if you put it in terms of energy required for recycling, reusing and all that, the smaller the circle is from disposal, the lesser is the carbon footprint incurred. So, and the energy conservation, right? So if it is reused, the entire energy is conserved, right? Whereas if you are going to refurbish it, you are spending some more embodied energy in replacing that particular component. So there is a little more higher carbon footprint. But when you go for recycling, there's even more carbon footprint because there's a lot of processes involved in recycling which incurs energy and emissions. And the longer you keep it in use, the better. That's why we need to build products to last. You keep it in use for a very, very long time. That is the best. Okay, again, putting it in the context of circular economy, we don't have to worry too much about this side, the renewable resources which go to the end of the life, because they are some way nature takes its role, and we can facilitate nature by providing anaerobic digesters or composting units and all that, and recycle it back into the environment. The complexity is here in the finite materials or the non-renewable materials, where you're going to have a lot of energy, effort, okay, for the recycling. The same thing concept, we're putting it in the where does it go back, right? User to user, reuse or sharing. Then service provider, when you're going to just prolong it by just refurbishing it, then it goes back to the manufacturer, and then for recycling, then it goes into the original production when you recycle it. Okay, so the longer the circle, the more the energy incurred. Okay, so I'll stop with this chart. It's kind of a reflection on what is happening across the world, right? So we have different groups already made, right? So we can make some, you can just observe this picture. Is it, are the numbers readable? So this is what happens at end of life world scenario. Okay, so each one, probably this group can take up UK, right? The one behind on the other side can take up China. You can take up Europe, EU, and just reflect on this. India, this group can take up India. Here, Africa, the first two benches. Then we have Brazil, okay, the last group there. And over here, you can take up Mexico. Is everything covered? US, Mexico, Brazil, Africa. Okay. So what is this chart telling? You can pay it, look at it for a minute. These legend here, I will explain. This is per capita waste production, your garbage bag. Okay. And then this is recycle. Okay. And this informal recycling is indicated by a push cart. Okay. So black is per capita and gray is 10-year projection. Okay. The garbage bags. And this indicates waste to energy. You can see the chimneys of the incinerator. So waste to energy, dark is existing, then it is planned. Then finally, when you see this, it is a dump or disposal. So how do each countries fare? Your designated country.
The per capita production of UK is 521. In the 10 years, they want to go for a 513. So it is about very less, a 2% drop because their lifestyle, I guess. So they cannot go beyond that level, I guess. So, but they are trying to recycle or the collection, everything very much professionally, and it is an informal. Actually, there is no informal collection procedure for this, and they are having 14 energy recovery sites now, and they want to go for a 80 more in next 10 years. Yeah, actually, if I compare with the yes, ma'am. If I compare with the rest of the country, so they are very much high in terms of the proposed or planned recovery sites, and 49% is the disposal that is going for the landfill or the end of life thing. But we don't know. Maybe they have projections. If they go for a 513 per capita production of waste, that they may have some projections for the, for the end of life rather than 49. They might have something like a 42 or 43. I don't know. I cannot see here, but there must be something on this. Actually, the facilities, they say like waste to energy facilities. So if we say in per capita, they are having highest among rest of the parts, because they're already having 14 and they are projected for 80.
Per capita waste generation is as of now 268 kg per hour, and in next 10 years it is going to be increased by almost like 2 times, 105%. And there is no, like in this projection there is no proper recycling, and it is like informal recycling. And the informal recycling, then most of it going for dumping, and then incineration is almost 37%. And the same next 10 years also it is just decreasing by 1%, almost same incineration they are doing. Yeah. Like incineration. And there is, as of now there is no proper recycling rate is not shown in China.
So as of now, Europe is generating second highest per capita annum waste, and in the next 10 years, it is around 10% increase. So it will be around 594. But they are doing like pretty much in recycling. Around 43% of their waste is going to recycle, and they are one of the highest like waste to energy energy recovery. So they have like 422 units, and in the next 10 years they are not doing pretty good. Like they are just not adding 14 units, and Europe is dumping only 30% of their waste. So this is the lowest waste among these countries.
So from the map that's over here, we see that the global north countries have reduced much of their dumping into the landfill, but most of the waste, not most, I think I got a data like back in 2019, around 1 million tons of plastic waste was exported from the United States to Senegal in Africa. So that the global north countries are exporting their waste to Africa and treating Africa as a dump yard for their own waste. So, and Africa doesn't have the infrastructure to manage these waste in their countries. And that's why we see that 100% of their waste goes into the landfill. And not just US, Europe also exports most of its electronic waste to Africa, especially clothing. Around 46% of not used clothing gets exported to Africa. And most of those clothing are of poor quality and they can't be reused again, so most of them ends up in landfill. So, and also Africa is one of the least developed continents, so that's the reason that they don't have enough infrastructure. And it's the responsibility of the global north to fund the transition in Africa. And there is Basel Convention which was signed back in 1990 to limit the export of hazardous waste from the global north countries. The United States has signed the agreement but hasn't ratified it yet, which means they haven't made the process a legally binding one. So that's the reason that the data is much extrapolated for the Africa.
Yeah, we didn't touch upon the hazardous waste yet. That's a whole different ball game, and no huge challenge in industrial waste and hazardous waste. Yeah, but you're right. Africa, Asian countries continue to be the receiving grounds. So China, I think, closed its door for imports a while ago. But then it all got dumped on Indonesia, Malaysia. Their waste intake went up. The sad thing is they are happily receiving this waste. So because there is a whole market associated with that, no, without considering the impact on the environment, health, and all that. So that's a sad scenario. Okay, next we'll go for Mexico.
Hi, I'm from Mexico. From the graph, you can see we have least population, but we generate more waste. And we have no waste to incineration plan. We don't do recyclable. We only dump into the grounds. I think so. The government should take action to mandate everything and to at least build a single or two-digit in incineration plan to develop the country.
So currently, for Brazil, we have 378 kg per year. It's a waste, and we have zero recycle option and zero energy recovery. 100% of disposal is going in disposal. So, and they have a projection of 584 per capita for next 10 years. So, as per our observation, what area need to be focused for Brazil is need lots of infrastructure investment management and funding, and also education for general population how to segregate it, and also awareness for health hazard for unplanned disposal of all the waste in their land. Thank you. So as per our data to 2012, we have 192 million. It's a population. So probably it's all data. So current now we are at 2020-25. So probably it will be higher.
Okay, for the US, when we see look at the other countries, the population is just 312 million, but the per capita waste generation is very high. It's the highest in the all amongst all countries. So the main reason I think according to this data it is 730, but as of latest 2025 it is already 951 kgs actually per capita. Yeah, they have receded already. Yeah, and only 24% or now as of recent 30% they are only recycling. Half of the waste is being dumped. So the major reason could be because of the consumption rate in US. The people don't go for the R usually; they just dump. And for the infrastructure, they have 86 energy facilities, but they're only thinking of uh, inculcating 3 more. So I think they should focus on more that. As of comparing to Europe, I think EU, they have similar population. So I think they should learn something from EU, and they have energy facilities almost 400.
Unlike what we are seeing, that difference is not shown in this graph. Like India and Africa, it is still dumps, whereas the other countries have invested in a proper landfill, those who are dumping. Okay, yeah. India.
Hi everyone, I am Shanawaz from Team India. As we look India, we are a population of 1.4 billion and growing. We are having the least per capita, that is 183 kg per year. While comparing with other developing countries, it's like from Mexico and Brazil, we are less. And comparing with also China, because China is also having the highest population. But the thing we should keep in mind that China is known as the hub of industries. Lot of waste is generated, and when we can see that India is informal recycling. Maybe we are doing recycling, as we in our classes we saw that we are instead of like thrifting clothes and like these things, but these are unorganized market. There like many startups can come and make it an organized sector of recycling. This could be becoming India as a global power, could increase. We should think on this. And we can also see that waste to energy is very less comparing to other countries. Why it's less? First thing is that Indian solid waste contains lot of water content that is not appropriate for waste to energy conversion. And one more thing is that when we are thinking of waste to energy, only in other countries also are doing waste to energy, but still they are high, because like waste to energy they are considering only one type of waste. So that's also we should keep in mind that segregation and that end of life. What are the new technologies we can bring? How to dispose it? New things. People more should involve on this. These things should be there. And also there is a lot of potential. Still we are in one. But if we can think as Chennai is sorting lot of waste and segregation is really good. There are many startups can come, many things, and we have lot of scope and potential. That 183 that is projected 208, maybe in coming 5 to 10 years it can be reduced to 150. And the people from other countries can learn from India about this thing. And Yeah, we are dumping around 91%, making longer than Qutub Minar. Hope like from Qutub Minar, our focus is not building Burj Khalifa from that, but our focus should be like legacy landfill. That the thing is that we are trying to legacy how we can from legacy waste what are the waste segregated and can bring out to new value, reuse, refurbish. Maybe energy is going to use, but thing is that we should focus on reducing from Qutub Minar to maybe I'm not able to recall like other short any monument, but maybe some like Taj Mahal is hope less than that. Maybe from Qutub Minar to Taj Mahal height. Thank you.
Probably that's again because of our traditional practices of not dumping everything. The per capita generation is low. Professor Su, do you want to reflect on this? Your thoughts? So the second part of the discussion after tea, we would like to know why this we saw the scenario and we saw what is the small circles and the big circles going from reuse to refurbish to recycle and all that. But so far, everything has been very, very qualitative, right? We know all this. We are seeing and all that. But why things are not translating into action? We know that reuse has to be done, recycle has to be done. But why is there so much of difficulty in implementing? You saw the scenario, the last slide. Earlier we talked about what is the best thing to do, but the reality was very, very obvious in the last discussion, right? So much is still going to the dump. Very little is getting recycling, and that too very informal recycling happening. No large scale, country level, large facilities. Why do you think? What has failed? I mean, collectively, we have all failed, right? The government, the experts who are advising the government. We all have to take the blame. One reason is that, like when you saw that energy audit yesterday presentation, right? We all know that we need to switch off lights. We will be wasting energy. We need to have the motors efficient. But it makes a difference when we put it in terms of numbers, right? He showed that so much of energy loss is happening, which will translate into monetary, right? That is where the eyes pop up, right? Even if you say like 1,000 units will be saved and all that, doesn't make that big of an impact. But the numbers he showed there from lakhs to crores, even for a small industry, small MSME, right? That made all our eyes pop up, right? Oh my goodness, there's so much money involved. So that is the strategy. No, one thing is looking at our emissions, carbon emissions, material and all that, and then comes the monetary. Two things we have to project. Now, sustainability is a big thing. Carbon credits, countries are going to, projects are trying to get carbon credits and all that. So it's important to project how much carbon credits we have to say the same thing in a different manner so that it gains attention of the policymakers, it gains attention of the investors, right? They are the ones who have to make it happen. We know as engineers, researchers, we know there is technology, we can build more technology, but then nothing is going on the field, right? How do we make it happen? These are the enablers, the government in particular. Okay, the industry itself, if it is generating waste and if it is creating waste downstream, let's say PET bottles we talked about earlier. So how can Coke or Pepsi rethink their design? Already they are doing it, right? They're not putting wrappers anymore. They're actually printing information on the bottle. That way, that wrapper is eliminated. A lot of changes are happening, right? But then how do we make them do it? Money will do the trick. And now sustainability is given so much importance that if we can show all that in terms of numbers, in terms of greenhouse gas emission reductions, carbon credits. We can show it in terms of water footprint reduction, right? That will be the next wave. It's not yet there as much as carbon credit. Soon we should start having all these credits coming in, right? How much water usage has been cut down. If we show everything in terms of numbers, okay, how much material, recycled material has been put in, right? So I think I brought some things for you to show during the break. I will show it to you. So you can track how much, if it says recycled polymer in the product, you can actually go and scan and find out how much recycled or how much is already there, where it came from. The industries have gone to that level of tracking because there's a lot of double accounting also happening. Carbon credit also failed because of all this, right? How do you track? Are they actually doing it, right? So now they have put in more efforts to actually say this came from this place. Okay, so digital passport, they call it product passport. Okay, so it's important to put things in numbers, and that is what I wanted to do in the next after the tea break. I'll show you some of the data which you may be using to get those numbers, right? So to make a product, how much of embodied energy is incurred in the product. Okay, so that translates to where these materials come from, right? Materials are the ones which end up as waste at the end of the life. So it's important to understand materials, okay, and the properties of materials which which we can quantify so that we can make an impact on the investors and the policymakers. So policymakers, if we can talk about what is the availability of the material, to compare different materials, it's important to know where these came from, what is the stock, how much is being produced. We may have a lot of bauxite ore, but how much are we getting in terms of aluminum? How much are we producing? How much materials are being produced? How much reserves we have? Okay, these are like the big things which policy level people should start thinking, right? How can we hold on to our reserves instead of just keeping on mining it? Okay, and so this gives you an idea what are the most annual world production in tons per year. You'll see that oil and coal and concrete tops the chart, right? Biggest material, the large volumes of construction which is happening leads to large volumes of concrete being produced in the world, across the world. Then steel, again, it's because of the infrastructure, right? Huge, the biggest carbon footprints come from buildings. Okay, and so biggest material, we have heard that story earlier, but biggest material consumption also comes from buildings and infrastructure. Okay, so then comes all these others, alloys, and some of them, they may have less production, but then they may have more carbon footprint. Producing it will have more energy. Okay, they may be produced in small quantities, but it may incur more energy and more carbon footprint. So this is in a pie chart, this is how the distribution of these resources and how they are consumed. That is production, and this is consumption. Okay. And then how does it impact? I mean, we talked about only environmental parameters, right? Emissions, embodied energy, and all that. Cost, like I told you, even everything, only when it comes to cost, people will actually pay attention to you. So as the materials become go into criticality, when you say critical, that means, so here there is a lot of discovery of materials happening, and then they start producing it. You can apply it to any mineral, right? Even fossil fuels. Okay, so there is discovery of the mines and the ores, and then the production starts, and at some point the discovery, we run out of stock, right? That means this is where the peak comes down, the reserves coming down, and but the production, we have started more and Like if you remember one diagram which I showed earlier, we have become completely dependent on non-renewable resources, right? You saw that S curve going up. So you are dependent on these minerals, but the production has come down, the reserves have come down, and we are going to, that is when the cost factor plays a role. So when the material becomes more and more critical, less available, the cost is going to go up. Right? So this also is something which we have to keep in mind. So the circularity principles are not practiced as a way of life like how we want it to, because of these big picture, lack of awareness of this big picture, even by commoners, not only government and industry people. They do all this math, but the common people, they don't have, they're not having this awareness. Okay, so it is important to have an understanding throughout, from the common people to researchers to government to engineers, okay, about materials and their attributes. So this is a very good book, Michael Ashby. Okay, this is subscribed by IIT Madras Library, but you can also have online subscriptions, I think, for this book. It's a very good book on eco attributes of materials. Okay, all about materials, their properties, how to design products, okay, based on choice of materials, based on the embodied energy, based on the impact these materials have throughout their life cycle stage. And they have given a very simple form of life cycle assessment called eco audit. Okay, with the properties what is given, you can make an eco audit, which is a surrogate, I can say, for LCA. Okay, so in this book they would have given these, they list these as eco attributes of material, of any material. You can say plastic, HDPE or LDPE, or silver, gold, in terms of metals. Okay, so they have the properties, eco properties or eco attributes listed for all materials. If you want some properties for your project also, I think if you are free to use this book to find out what is the embodied energy of the materials which went into your product, right? You will be needing some of the data, let us know. Okay, and it also has information on the carbon emissions during manufacturing, carbon emissions during the primary production, use stage, water usage, and finally all the environmental toxicology parameters, like you talked about ozone hole, no, ozone depletion, we talked about greenhouse gas emission, eutrophication, all toxicity parameters. They have put it together in the form of an eco indicator, like a weighted average they have used for all the toxicity impacts, has been put together as eco indicator. So we can compare different materials. We'll do some problems when we come back, so that will help you how to use this data for every material to understand between compare between different materials, right? Like I said, we have to design products in such a way that it has low impact throughout the life cycle, including end of life. Okay. So it will help us put things in perspective and put some numbers. That is what is more important, right? I can't say that let's say this one, I think it's made up of some plastic material, the outer casing. Is it better if I had used an aluminum frame, right, or not? How do we decide? Any product, you can say, if you want to use a different material, how do you say that? How do you compare them? The first thing is function, right? No compromise. And when we are looking for environment impact and all that, again, there should be no compromise in the original function. We want it to be there to hold the bulbs. It should not get heated up. Lot of things are there for the function of this product, right? So that should not be affected. So it needs a certain, the thermal properties, physical properties, right? If it is a building material, it has to have the correct compressive strength, right? You cannot compromise on all that. The main function, that is primary. It also has materials. The properties of the materials are also listed so that you can have a proper comparison, not just the eco properties. In addition, it also has all this. How much global production of that material, how much global reserves are there, embodied energy of the material. So we can use all this to understand which product is better, the one made with this material or the one made with this material. Okay, looking at all the life cycle stages also. But we may not be able to do the entire life cycle stages, but we will take little bits of these and do some number crunching, which will help us understand why we need to talk about all these eco attributes and how it makes a decision considering even the end of the life. Okay.